Concentrated solar power uses thousands of mirrors to reflect and concentrate sunlight onto a central point to generate heat, which in turn is used to generate electricity. More than 10,000 tracking mirrors called heliostats reside in a 4 square mile field where they reflect and concentrate sunlight onto a large heat exchanger called a receiver that sits on top of a 550-foot tower. Within the receiver, fluid flows through the piping that forms the external walls. This fluid absorbs the heat from the concentrated sunlight. In this technology, the fluid utilized is molten salt, which is heated from 500 to over 1,000 degrees Fahrenheit. Molten salt is an ideal heat capture medium because it maintains a wider operating temperature range in liquid state, allowing the system to operate at low pressure for superior and safe energy capture and storage. After passing through the receiver, the molten salt then flows down the piping inside the tower and then to a thermal storage tank where the energy is stored as high temperature molten salt until electricity is needed. This technology leverages liquid molten salt as both the energy collection and the storage mechanism, which allows it to separate energy collection from electricity generation. When electricity is required by the utility day or night, the high temperature molten salt flows into the steam generator as water is piped in from the water storage tank to generate the steam. Once the hot salt is used to create steam, the cool molten salt is then piped back into the cold salt storage tank where it will then flow back up the receiver to be reheated as the process continues. After the steam is used to drive a steam turbine, it is condensed back to water and returned to the water holding tank where it will flow back into the steam generator when needed. The result is a high quality superheated steam to drive the standard steam turbine at maximum efficiency to generate reliable, non-intermittent electricity during peak demand hours. The steam generation process is identical to the process used in conventional gas, coal, or nuclear power plants, except that it is 100% renewable with zero harmful emissions or waste. These plants provide on-demand, reliable electricity from a renewable source, the sun, even after dark.